Buenas noches! January 26, 2019. Our subject tonight is Polyhedra groups. We'll start with 20 faces Polyhedra. We have also 12 faced Polyhedra, an 8-faced Polyhedra, a cube 6-faced Polyhedra, and the tetrahedra. Well, this is the second video. What has been changed? 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 I renamed everything. My project is Polyhedra, uses Polyhedra, unit principle. My object is projection, the opposite, the isometry, the form principle, the side, the tetrahedra 1 and 2, the 4 points, octahedra 6 points, cube 2 8 points, dodecahedra 1 and 2 20 points, icosahedra 12 points, show polyhedra, rotation, this is Portuguese, tetrahedra group, octahedra group, cube group, icosahedra group, and dodecahedra group. Let's explain what's going on here. The straight line, I have already explained it. The distance is explained. The norm is explained. The determinant is explained. Rotate x is explained. Set x, y, z is explained. Projection is explained. Opposite. X is opposite Schroeder dot x if it's 0. Its absolute value is less than an error for x, for y, and for z. And close. This is true or false. Opposite or not opposite. The average is explained in R2, in R3, in R5. 0 unitary is explained. Rotation and axis is explained. My theta is p over 18. Form key press is explained. Show polyhedra is explained. Circle is typed. Spiral is typed. Edges 3D is explained. Now, if I have checked my CB4, checkbox 4, I will draw the line. 1, 2, 2, 3, 3, 4, 4, 2. Move to 1, 1, 3, move to 1, 1, 4. And do the tetrahedra group. If CB6 is checked, we draw the lines 1, 2, 2, 3, 3, 4, 4, 1. 1, 5, 5, 6, 6, 7, 7, 8. 8, 5. Move to 2, 2, 6. Move to 3, 3, 7. Move to 4, 4, 8. Do the cube group. If CB8 is checked, always in blue line, 1, 2, 2, 3, 3, 4, 4, 5, 5, 2. Move to 1, 1, 3, 3, 6. Move to 1, 1, 4, 4, 6. Move to 1, 1, 5, 5, 6, 6, 2. And do the octahedra group. 12A is explained. CB20 is explained. I added the icosahedra group. 12B, check it. I added the dodecahedra group. And Timer is explained. Show polyhedra is explained. Form K down is explained. Vamos ver, let's see. Ordenar, order is not being used. Form create. What have been added here? What are the coordinates of the tetrahedra? 0, 0, 0, side 0, 0, 1 half square root of 3 over 2, 0, times the side over 2, side times square root of 3 over 6, sides times square root of 6 over 3. Let's see. Here is the coordinates of the tetrahedra. Oh, now the cube. The cube is 1, 1, and 1. Let's see. Minus 4 plus 6. 0, F2. Here is the cube. Okay. The octahedra, what are the coordinates? Minus 1, 1, minus 1, 1, 1, and minus 1, 1 at the plane z equals to 0. What is the height? 1 squared plus 1 squared plus z squared is 4. So the z is 1 plus or minus 2. The dodecahedra is explained. The average of the faces are explained. The verifications are explained. It is ordered. And now the tetrahedra group. What is the tetrahedra group? Don't worry. As you know, by topology, there are only 5 possibilities of a regular polyhedra. The 4, the 6, the 8, the 12, and the 20. The rotations and the reflections of a polygon in R2 perform the dihedral group of a polygon of n faces and n sides. It has 2 n elements. It's not an abelian group. The rotation is a basic element and the reflection is a basic element for describing polygons. How to describe a polyhedra? The tetrahedra group is made by the permutation of 4 vertices A, B, C, D. And here are 24 permutations. Example, the identity F from ABCB equals to ABCD. 4 times 3 times 2, 24 isometries. Okay? Let the cube be ABCD, E, F, G, H with edges AB, AC, AE. The word ABCE. At the position A, there are 8 possibilities from A to H. At the other positions, there are 3 times 2 possibilities. BCE, BC, CBE, CE, BCBE, EBC, ECB. The identity transforms ABCE to ABCE. 8 times 6, 48 isometries. It is not Z48. Let the octahedra ABCD F with edges AB, AC, AD, AE. Let the word be ABCDE. At the position A, 6 possibilities from A to F. At the other positions, a circular permutation of 4 possibilities BCDE to CBED. We rotate C joined with D, D joined with E, E joined with B, and B joined with C. Backwards, B, E, D, C. Here appeared the dihedral group of the square, 8 elements. The identity is transforms ABCDE to ABCDE, but we need only 4 points to describe an isometry. Another time, 6 times G-hedral order of the G-hedral of 4, 6 times 8, 48 isometries. Now the icosahedra. The 30 edges are AB, AC, 2, K, L. At the position of A, there are 12 possibilities from A to L. Let the word be ABCDE key. At the other positions, there is a circular permutation of 5 possibilities. Here appeared the dihedral group of the pentagon. The identity transforms x to x for all x. 12 times 10, the order of the dihedral group of 5. 12 times 10, 120 isometries. Now the dodecahedra, it has 30 edges, a K to ST. At the position of A, there are 20 possibilities from A to T. Let the word be AKOS. At the other positions, there is a circular permutation of 3 possibilities, the dihedral group of a triangle. The identity transforms ACOS to ACOS. 20 times 2 by 3, 20 by 6, 120 orthogonal matrices 3 by 3. Exercise. Now let's determine the 24 plus 120, the 360 orthogonal matrices above. The system is always 12 by 12. A matrix T times A added to a vector V equals to E. TB plus V equals to F, TC plus V equals to G, TD plus V equals to H. T has 9 cells, V has 3 cells, so we're gonna solve 360 linear systems. Here is the system. Find T, find V, AT, VE, DT, VH. In matrix form, here is the system. A lot of zeros, a lot of identities, and it's easy to scalinate, pivotiate, do the theorem of Kramer rule. Subtracting the ones at the end, the 3, 6, 9, 10th, 11th, and 12th columns. We have a 1 here and all zeros above 3 times. Here we get V1, here we get V2, here we get V3. What remains above? Subtracting the lines 10, 11, and 12, it reduces to a 3 by 3 system where M is this little matrix, A1 minus D1 until C3 minus D3, and M times T1 to T2 T3 is equal to E1 minus H1 F1 minus H1 G1 minus H1. Another time, M T4 T5 T6 is equals to this vector. M times T7 T8 T9 is E3 H3 F3 H3 G3 H3. Now it's high school. I asked to the professor, does it worth 1 million? Maybe at Venezuela. Let us do that for polytopes. In Rn, natural n greater than or equal to 5 for a simplex, for a hypercube, for a orthoplex, and for n equals to 4. There are other things at Wikipedia. Error at sending. I'll try to send it again. Polyhedra groups at Dropbox. Okay. Where was I? Here. The group of the tetrahedra. Which is it? I have byte counters. I, J, K, L, M, N counter. I have one isometry and the real determinant number. And for the 4 vertices of the tetrahedra, A, J, I, J, K, L. I want that J is different from I. I want that K is not I and K is not J. I want that L is not I, is not J, is not K, so I could calculate the L, but I did it. And if all this is satisfied, what will we do? We will exchange the tetrahedra 2 by the tetrahedra IJKL, our permutation. And by Cramer's rule, the T is a determinant divided by another determinant. This is done several times. T2 is divided by that M. T3 is divided by the determinant. T4 is divided. T5 is divided. T6. Let's go back. Tetrahedra group. T6 is divided. T7 is divided. T8 is divided. T9 is divided. And what is the isometry V1, V2, and V3? We, by our matrix, we get H1, D times T, D times T, D times T, and here we have V1. dt, dt, dt. Now I put the answer at a t memo, and I increment the counter. And which is the solution? For the polyhedra, we have 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3, 2, 2, 1, 3, 4, 2, 1, 4, 3, 2, 3, 1, 4, 2, 3, 4, 1, 2, 4, 1, 3, 2, 4, 3, 1, 3, 1, 2, 4, 3, 1, 4, 2, 3, 2, 1, 4, 3, 2, 4, 1, 3, 4, 1, 2, 3, 4, 2, 1, 4, 1, 2, 3, 4, 1, 3, 2, 4, 2, 1, 3, 4, 2, 3, 1, 4, 3, 1, 2, 4, 3, 2, 1. And here we go to the six faces. We have 48. For 8 faces, we have 48. For 12 faces we have 120, and for 20 faces we have 120. What should I do now? Anything. Show the memo. Let's show. Here is the memo. Here is not the memo. Cube group, the same thing. 8 points. We don't want the distance from the first cube to the second cube is equal to 2 with an error. We don't want the distance from I to k is equal to 2. We don't want j equals to k. We don't want the distance from I to L equals to 2. We don't want L equals to j. We don't want L equals to k. And the cube 1, 2, 4, 5 is the same reasoning. The octahedral group is the same reasoning. So there are 6 points. I, j, k, l. The octahedra, the opposite of 1 shall not be j. The opposite of I shall not be k. The opposite of I shall not be L. I shall not be j. K shall not be I. K shall not be j. L shall not be I, j, k. And the distance from j to k is not 2. The distance from k to L is not 2. And the same reasoning. The icosahedral group, we fix the side, the distance from the point 1 to the point 2. The 12 points, I, j, k, l. The distance from I to j is not side. From I to k is not side. From I to L is not side. And from L to j is greater than the error. We want that it is not the side. It's different from side. So the modulo is greater than the error. And this condition says that the distance from j to k is equal to the distance from k to L. This worked. We don't want k equals to ij, L equal to ijk, and the same reasoning. The dodecahedral group, the same reasoning, with less ifs. Distance from I to j equals to side. Distance from I to k equals to side. Distance from I to L equals to side. And here is the caption. And it is the same reasoning. And here is the memo point to hide at double click. And here is the memo point to show at double click. And here is the memo dot hint. So if you want the hint, here is the hint. Here is the 0. And out of charity, there is no salvation at all.